Dear students, welcome back into the another session on software testing. Students, in the last lecture we discussed about the static and dynamic testing. By now we know what is a static and dynamic testing. We know the difference between the static and dynamic testing. Just we will take a quick recapitulation on the static and dynamic testing. So basically a static testing is done without executing the software. So generally in the case of static testing, you scan the documents, you inspect the documents, you see whether the documentation is done properly or not. You go through the code and you see whether the proper guidelines are being followed in the code writing or not. That you do in the static testing. So in general, you don't execute the software in the case of static testing. Whereas in the case of dynamic testing, you have to execute your software. So you execute the software, you run the test case, you provide the input, you observe the output, and by having the knowledge of the outcome, you decide whether the test was successful or not. So that's what it's called as a dynamic testing. So in the case of dynamic testing, you execute the software. That's why it is called as a dynamic testing. Now in today's session, we will first start our discussion with the V model. So as you know, you have already studied the V model in the software engineering. This model is called as a V model because when we look at it in vertical manner, it looks like a V, English letter V. That's why it is called as a V model. So now V model is very important in the software testing because this model gives us the input for the testing. So for example, you start with the requirement specification. So this is how your waterfall model works. Simply if I will observe requirement specification, then the system specification, system design and detailed design, and then we have the actually software coding. So all these phases are a part of waterfall model. Similarly, if we take each and every step of this waterfall model and we give the input for the testing, we get different sorts of tests. So for example, when we have the requirements in our hand, we can decide the acceptance test plan and we can write down the acceptance testing. Now basically what is it, acceptance testing? So basically requirements are given by the user, isn't it? So user knows how the software should work, what is the real need of designing the developing of that software. So he knows whether that things are fulfilled or not by testing the software. So that is done at the time of acceptance testing. So in the case of acceptance testing, user of the software sits on the computer system and looks the software whether the software is perfectly working according to his requirements or not. So that is nothing but the acceptance testing. Then we have next as a system specification, which is a part of waterfall model. So when we write down the system specification, that will give us the input for the system integration plan. Because when you are writing down the system specification, you are combining different modules. And as you are combining different modules, you can work with the integration testing. So that is nothing but after developing each and every module, how you are going to integrate them, what will be their interfaces, that you are going to see in the system integration testing. So system integration testing can be done or developed using the input of system specification. So basically each one of these components are actually contributing into the testing plan and designing the test cases in the software testing. So as you can see over here, this requirements and the system specification, these two phases of the waterfall model are contributing into deciding the acceptance testing. So by having the knowledge of acceptance testing, we can decide the acceptance test plan. Then having the knowledge of system specification and system design, that these two things will contribute into system integration test plan. So basically you can decide or you can design system integration testing by these two different modules inputs. Then you have a detailed design. Once you have the system design in your hand and then you move on to the creating a detailed design, then you can actually contribute into the subsystem integration test plan. So that will contribute into designing subsystem integration plan, and that will create test cases for the subsystem integration. Similarly, once you have a detailed design of every module in your hand, you can decide the unit testing. So that is nothing but a unit testing is nothing but you are creating a test cases for individual unit. So as we are designing the test cases, we generally start with the unit testing, because every time you have the small unit in your hand for the testing, at one glance you will never have an entire system in your hand, isn't it? So generally how it will proceed, so you will proceed with having the small units in your hand. So once a small team of software developer has designed a unit, a small module of your software, then you can proceed with the unit testing. So this detailed design will give you the inputs that what needs to be tested in the unit code or unit testing. Once the unit testing is done, then you will combine multiple units together and you will carry out integration testing afterwards. So that is nothing but integration testing will be actually testing different interfaces between the modules. So once you have done with the unit testing, means individually units are tested, then you have to observe their interfaces. As we have seen in the case studies of Mars lander. In the Mars lander case study, we see that in that unit testing was done properly, but in that case integration testing wasn't done properly. So once you have observed the units are performing as per the expectations, then you have to observe their interfaces and whether their interfaces are working properly or not. The unit transition means when you are sending the data from one module to another module, whether it is intact, whether it is consistent across entire system, that you have to observe in the subsystem integration testing. Once you have tested one or two modules in their integration manner, then you have to test entire system as a whole for the testing. Means here you have to give the input and you have to observe the output. So here you don't actually consider internal details, but you just consider input of the system and the outcome of the system. So all different modules you are treating as a whole system, as a one system, and then you carry out the testing. So that's why it is called as system testing or system integration testing. Once the entire system is tested as a whole, then we have to move on to the acceptance testing. Now the difference between the system testing and the acceptance testing is that system testing is carried out by the testing team, whereas in the case of acceptance testing, in the presence of testing team, client of the software will use the software. So client will decide whether to accept that software or not. That's why it is called as acceptance testing. So acceptance testing is very crucial and it is directly related to your requirement specifications. Because what customer has stated in the requirements, that will be actually tested in the acceptance testing, and then customer will decide whether to accept the software or not. If customer is of the opinion that requirements are not fulfilled, then customer can refuse and then acceptance testing will fail. So that's why acceptance testing is a major milestone in the software development and software testing, of course. So in the software acceptance testing, software will be executed in the presence of developer, but here the software will be used by the client of the software. He or she will see whether the requirements are fulfilled or not, and then he or she will approve whether that software will be accepted or not. So once the acceptance testing is done, then software will go into the service phase. So here the software is going to be get released, and then the next service part of the software will start. So here customer will start using the software, and whatever the need of the customer, in case if there are some changes or in case there are some upgradations, that will be provided by the developer. This is how V model is helpful in the software testing. Now next we wanted to study entry and exit criteria for the software testing. Now as you know that testing entire software is not possible. You can never test 100% of the software. I gave you a simple reason and simple example for that. Let's say you have written only 4 to 5 lines of code for the addition of two numbers. Now in order to test that code entirely, right from with all the possible combinations of inputs, it's not going to be get possible. it will take infinite time because you cannot have the input in your control, isn't it? So you cannot test your software completely. So basically you have to find out the best threshold where you have to stop. So there is an entry and exit criteria that needs to be fixed. So the first thing is that when you are going to start your testing, so that's nothing but the entry criteria for the testing. So here the entry criteria will tell, here there will be a distinct boundary to understand the software developer and the software tester that when to start the testing. So probably over here in the project management, proper criteria would be written. If the one module will be completely done, then probably testing can be started. If requirements have been gathered, then another testing can be started. If software's 2 modules are ready or 80% of the code is ready, then testing can be started. So basically depending upon the different software and its nature, entry criteria can be different and it can be finalized by the project manager. So here the entry criteria is a distinct level or it's a distinct line from where the testing team will take the control of the software and they will start taking the testing on the software. So that's why it is called as an entry criteria. It needs to be finalized. It should not be vague. It should not be blurred to understand, because otherwise there will be an entire chaos in the software development and the software testing. Means a developer will start asking, okay, now it's done, now you can start for the testing, but probably testing team is not ready with the plan, testing team is not ready with their test cases. So this entry criteria needs to be finalized and it should be known to both parties, whether it is a development or whether it is a testing team. They should know that entry criteria. So once they know that after 70 to 80% of the code has been written, then they can start with the testing. Probably by that time testing team will prepare their test cases. So accordingly there will not be any mismatch in their timings. So that's why this entry criteria should be properly designed and it should be known to both the parties in advance. Then once the entry criteria is met, testing will start. Then process activity, in the sense the testing will be carried out. Now how long we have to keep on doing the testing? So for that purpose we should know the exit criteria of the software testing. So we should know when to stop. Now probably it will be like if the 60 to 70% of the major test cases are done with the proper outcome, then we can stop the testing. Now here this exit criteria should be finalized by the project manager, and that depends upon the nature of the software again. If the software is very critical and you want to test it very extensively, you have that much time and you have that much funds and all the budget, then you can go with the deciding the exit criteria with the extensive testing. But if the software, if you have tested properly and 60 to 70% of the test cases are done with the execution and the outcome of that test cases are right, means they are executed successfully, then probably you can decide with the exit criteria and you can decide to release the software or you can stop the testing. So this exit criteria should be decided properly. Now here is the graph which will tell you how it is difficult sometimes to finalize the exit criteria. But if you have this proper graph with you and if this is properly budgeted, if it is properly projected, then this exit criteria can be easily found out. Now here this curve will tell you amount of time will be given for the testing. Now if I will start doing the testing, okay, now this is the timeline, okay, how much time I am giving for the testing. So as you go along with spending more time with the software for the testing, the cost associated with the testing will go on increasing. This is very relative, isn't it? If I have decided I will spend 5 days for the testing, obviously I will need to engage all the resources only for the 5 days. But instead of 5 days, if next I will decide to spend 15 days for the testing, I will need to engage my resources for the 15 days. So obviously the cost associated with the testing will go on increasing. But there is another graph which will tell us how much amount of faults or how much amount of defects or bugs I am going to get throughout the testing with the respect of timing. So as you start with the testing, initially you will get more bugs, and these bugs are really prominent bugs. Those needs to be get fixed because they are critical probably sometimes. They are very major. So as you start with the testing initially, you will start getting more and more number of bugs. But as you move along with the time, these amount of bugs that you will get will start decreasing. And as you spend more time with the testing, probably you will start getting lesser and lesser bugs afterwards. Means for example, most of the bugs you will get found in the first 5 days or in the initial phases of the software testing. But if you keep on testing the same software again and again and again for after a certain duration, 5 days, 10 days, 15 days, 20 days, even after spending those much time, you will not get that many bugs that you got in the first 5 days. Because most of the bugs you will get and which are really prominent, that you will get at the starting phases only. So that's why this is called the sweet spot where you should stop your testing. So this is nothing but the threshold of your budget and the time where you should stop your testing. So once you got to this threshold, it is safer to stop the testing, because if you continue afterwards, then you will go incurring with the more and more cost, but the amount of bugs that you will get with that will be very lesser. So that's why you should always stop your testing at this particular phase. That's why it is called a sweet spot. It is a threshold spot where ideally you should stop your testing. Now we will study static testing in detail. So in the static testing, generally we carry out reviews and the static analysis. And here the sole purpose of doing the testing is to produce a high quality product with the high quality documents. We never execute anything on the actual component of software, but instead this is kind of a review. So that's why it is called a static. We don't have to do any dynamic things over here. In the sense, we don't have to execute the software over here. That's why it is called as static. So in the static testing, we go with the reviews and the static analysis. There are many other things which are coming under the static analysis or static testing that we will see now. In general, we have this sort of flow for the software development. We have the requirement definition, then we have a functional system design, then we have a technical system design, then there is a component specification, and then finally we have the programming. So in the static techniques, we generally focus on the specifications. We wanted to find out the defects in the specifications. Those can be found only through going through the documents, isn't it? We cannot execute anything over here, so we read the documents, we read the specification, we find out inconsistencies if there are any with the specification and the requirements, and then we figure out the defects in that. Then we have design our architecture in our hand. So here we compare that with the specifications. We already read the specifications, we already have the defects. If we have any, then we have found out that and we have fixed that in the specifications. Now after having the specifications done properly, then we go through design and the architecture of the system, and we find out defects in that. So in the design or in the architecture, we have different diagrams, like we have flowchart diagram, data flow diagrams, different DFD diagrams. So those diagrams will be checked over here. And if we find any inconsistency in the design or architecture, that can be figured out over here. And then those can be fixed right in the design or architecture phase only. Once that is done, then we have the interfaces also. That is interface specifications. So as I told you, there are different modules which are tested, which are developed independently and then afterwards tested. So here we have to observe their interfaces. So here we observe whether the interfaces are consistent in their units. Means for example, I gave you the example of Mars Land Rover. In that we are sending data in the one unit and receiving data in the another unit. If that is going to be done, because here units are developed independently by different software programmers or different teams are working on them. So here we should have the clear-cut interfaces. So we should know what data is being sent from one module and what it is going to be received from the another module, and how another module is going to treat that data, in which particular unit it is going to treat that data. So that's why these interfaces needs to be tested very clearly. So once extensively we have tested interfaces, then In the static techniques, we have other attributes also that we concentrate upon, that is the maintainability of the software. So if everything is perfect, like your specification, designing and interfaces, everything is perfect, but code is very complex to understand, or if it is too much complicated, then maintainability cannot be achieved. In software development and as well as in the software testing, we have to focus on the maintainability of the software also. This maintainability will give us the flexibility to upgrade the software in future if required, or if there are any bugs, those can be removed without putting lots of efforts in it. So without putting much efforts in the software fixing, if we wanted to get the software through those entire phases, then this maintainability should be focused upon. So that's why in the static techniques we have other focus other than the specification, designing and interfaces. We have a focus upon the maintainability of the software. So in the maintainability of the software, we always observe how clearly system has been represented, whether each and every module's purpose is clearly mentioned, what every module is doing, what is the role, what input they are going to receive, what output they are going to produce. Everything is clearly defined, that we observe. And if required, we can simplify the system further in order to achieve the good maintainability of the software. So this is how static techniques, in which we focus upon specification, design, interface and maintainability of the software. Now we will see advantages and the drawbacks of static testing. Now there are more advantages than the drawbacks, but still we have to focus on the other side of the static testing also. So we will see the drawbacks also. So basically advantages are more. So here, as you are going to test the entire documentation, right from the specification, then the system architecture, then the designing, then the interfaces, means before even the implementation will even start, you are testing the software documentation, you are checking the entire documentation. So there are more chances that you will get the problems or the bugs found in those phases. So as you are going to get these bugs in the earlier phases, entire budget can be saved afterwards. Means these bugs will not be get forwarded into the later on phases, and obviously that will save up the cost and that will improve the quality of your software. If at all we have to find out drawbacks of static testing, then we can enlist some of them, like we need expert person over here who will take a review of the software. This person should not be inexperienced. The reason, because as you are going to test the entire things with the imagination here, and the software is not in front of you, but just you have the specification. So you have to imagine the scenario, how the user will be using the software, what problems might be there, and whether we have handled these problems in those documentations or not, whether the design is foolproof or not, whether the architecture components are properly written or not. They are not that complicated. So in order to have those knowledge, you have to spend some time with your software system, and that too by the expert people. So that's the only drawback. But if you weight advantages over the drawbacks, we have more advantages than the drawbacks. So it's not that important to focus on the drawbacks of the static testing. So we have advantages only over here, and that we have to only focus. So it is beneficial to go with the static testing before you will start your implementation. That's it from today's session. Hope you have understood what we discussed in this session. I will catch you in another session. Till then, keep studying. Thank you.